Okay, great. Welcome back, students. In this section, we will be talking about the properties of arithmetic mean. Now, to understand the properties of arithmetic mean, it is very, very important. It reduces a lot of our effort to calculate some important to calculate some important concept or to calculate some important data, right? So, knowing proper of the arithmetic mean properties are very, very important to understand the entire descriptive statistics. Please understand, there are only four types of properties, okay, of arithmetic mean. So first one is if if okay, you are adding any constant value, okay, let's say constant value k, you are adding with all the elements, with all the elements of the observation, okay, then the arithmetic mean also will be added by this constant k, right? Now let's take an example. Let's say you are having in the observation 5, 10, 15, these three elements. What I am saying, if you add k, that means let's say in this k, let's say 5. So if you are adding 5, a constant value, with all the elements like this, then I'm saying the arithmetic mean also will be increased by k. That means in this case 5. Now, what is the arithmetic mean of this? 5 plus 10 plus 15 divided by 3. So I'm getting 10 is the arithmetic mean in this given problem, right? Clear? So herein I am adding 5 with each and every element. So in this case, what will be the arithmetic mean, final arithmetic mean? Am dash. So 10 plus 15 plus 20 divided by 3. So 10 plus 15, 25, 25 plus 20, 45 divided by 3 means 15. And 15 is nothing but 10 plus 5. Can you see? So what I have done, see this 10 and 5 is nothing but the k. Clear? So that means if you are adding a constant value k with all the elements of a given observation, then the arithmetic mean of that observation will be also increased by the constant value, in this case k or 5, right? Now question is it only applicable for addition? No, it is also applicable for subtraction and multiplication also, and the division also. Okay, so when I'm saying addition, instead of that you can do multiplication, you can do subtraction, you can do division, the answer will be same. That means it will be divided by, added by, subtracted by, multiplied by that particular constant value k with your arithmetic mean of the given data. So this is the first property. Now what is the second property? And in this property, what I said, this is most important for addition, subtraction, multiplication and also division, right? Now what is the second property? Second property says that the difference of the mid value from the average and this summation of all these values is always 0. Okay. Now the second, now what is the second property? The second property is saying if you are subtracting each and every elements, that means xi, x1, x2, x3 from the arithmetic mean of that given data x bar, and you make the summation of that, it will be always 0. And for frequency data, it is also valid. Now let's take three numbers, 5, 10, 15, whatever we took it previously, right? Now what is the average x bar? We have calculated x bar is 10 of this 5, 10 and 15, right? What I am saying, that if you minus this 5 minus arithmetic mean plus 10 minus 10 plus 15 minus 10, it will be always 0. Let's see, minus 5 plus 0 minus 15 minus 20, sorry, 15 minus 10, sorry. So this is plus 5. So this is 0. See? So this is valid for frequency data also. Clear? So this is very simple. Summation of xi minus x bar equals to 0, or summation of fi into xi minus x bar is equals to 0. This is the second property. Now what is the third property? Third property is, let's say you are given x and y, two unknown variables, and these two unknown variables are related by one particular equation, linear equation. Okay, let's say ax plus by plus c equals to 0 whatsoever, the linear equation, right? That means there are two variables x and y, and they are related by this equation. If it is given, and if x bar is given, then you can calculate y bar, or if it is y bar is given, then you can calculate x bar, right? Now let's take an example that x and y are two unknown variables, and it is given that 2x plus 3y plus 7 equals to 0, and given that x bar is equal to 15, then y bar will be what? This is our problem, and this is the property. We can, using this property, we can find out the details. Now what will happen in this case, that we will simply write like this: 2x bar 3y bar plus 7 equals to 0. This is the property. Okay, it means what? If xy is related with the same equation and the linear equation like this, then x bar and y bar also will be related accordingly. So this is the property. So in this case 2x bar is given, right, and 2 into 15 plus 3 into y bar, which we need to calculate, plus 7 equals to 0, and if we calculate, we'll get y bar is equal to minus 7 minus 2 into 15. Okay, that means 30, minus 30, and divided by 3, so we are getting minus 37 by 3, 12.3 roughly, right? Minus 37 by 3, 39 minus 12.3, something like that. So this will be the y value. So what means, what does this mean? It means that if xy are the two unknown variables and they are related with x plus by plus c equals to 0 in this equation, then x bar and y bar also will be related as ax bar plus by bar plus c equals to 0. And if x bar is given, we can calculate y bar, and if y bar is given, we can calculate x bar, right? And the last property is property 4, which we call combined arithmetic mean. It means what? Think that two data sets, x1 and x2, and it is given that x1 bar and x2 bar are two different arithmetic mean. It is given for two set of data, right? So x1 bar and x2 bar is two given set of data, and in x1 there were n1 numbers and n2 numbers. That means what? There are n1 numbers. The arithmetic mean of n1 numbers are x1 bar, and there are n2 numbers given, right? Another set of data wherein x2 bar is given. Then I try to understand, I will try to understand what is the composite mean or the combined mean of that. Think that I am the principal of a college. I want to know, it is given that 30 students are there in BSc and 50 students are there in BA class. Okay, so for BSc students, 30 students, their average mark is 15, and for BA students, example, BA students, 50 students, average mark is 30. So I want to know what will be the combined mean. So in this case, combined mean x bar 1 2, we call it 1 2, this one and this 2, we write it like this. So combined mean of two group 1 and group 2, and x bar, like this we mentioned, is n1 into x1 bar plus n2 into x2 bar divided by n1 plus n2. This is the formula. Now take the example whatever I have given you, right? Think that there is a BSc student group and there is a BA student group. So in BSc student, I said there are total 30 students, and in BA students there are total 50 students. And I also said that let's say 15 is the average mark for BSc students and 30 is the average mark for BA students. And total number of students are here in this case 30 plus 50. So this will be the combined mean of two section. And I can say that as being a principal, I can, whenever I am projecting any data, I am giving this speech to the parents, and I can say that in average the combined mean of the scores which in the final exam or the end term exam what BSc students and the BA students have got, that is the combined mean of x bar 1 2 is nothing but here in this case 40 450 plus 1500 divided by 3, sorry, 80, right? So this is 1950 divided by 80 and something like that, whatever, it's coming close to 25 approximately. It is coming 8 16 and 8 close to 25. So I can say that average 25 is the average score for BA and BE, sorry, BA and BSc students, all students put together. So this is called nothing but the combined mean, right? So hope you have understood these four properties of mean. First one is if you are adding a constant value with all the elements of the observation, then the arithmetic mean also will be added by that constant value. And the question is whether it is applicable, this property is applicable only for the addition? No, it is applicable for addition, subtraction, multiplication, division, all. Clear? Second property is the summation of xi minus x bar equals to 0, or summation of fi into xi minus x bar equals to 0. It means whatever the elements you have that in that observation, if you minus that, or if you minus the average mean of that observation from each and every individual elements, and you make the summation of that, you will get a 0 value. This is the important, one of the important properties of arithmetic mean. Third is nothing but if x and y are two different variables and they are related by a linear equation ax plus by plus c equals to 0, then x bar and y bar, that means the arithmetic mean of x data, set of data, and arithmetic mean of y also will be related to this ax bar plus by bar plus c equals to 0. And if x bar is given, you can calculate y bar. If y bar is given, you can calculate x bar. Fourth one is combined arithmetic mean. That means let's say there are two set of data. x1, there in let's say n1 number of data. In x2 group there are n2 number of data, as I given the example of BSc students and the BA students, right? So the combined mean will be nothing but x bar 1 2 equals to n1 into x1 bar plus n2 into x2 bar divided by n1 plus n2. This is called the combined mean or the composite mean. Both you can call combined mean or composite mean related to the arithmetic mean. And this is the fourth property of arithmetic mean. Hope you have understood. See you in the next section when we will talk about the geometric mean and its properties.